So let's go through and solve each one of these one by one. Get the hang of this. So as I mentioned before, if we graph y equals x squared, y equals 4, we can see that they intersect at -2 and +2. There are two intersections. So when we solve it algebraically without a graph, we should have two answers. The same two answers, -2 and +2. And big idea for all of this that you want to retain is that the square root of x squared is equal to absolute value of x. So when you take the square root of both sides, like right here, you get the absolute value of x equals the square root of 4, which is 2, and you break it up into two parts. X equals 2, x equals -2. And you can write your final answer like this. So I have that written down. Big idea is right there. Square root of x squared is absolute value of x. We have kind of two stages. We have the square root stage, when we get absolute value, and then we have the solving an absolute value problem. And we spent a couple of weeks on solving absolute values already. And we saw that you can move the graph from left to right. We took a quiz on it. So this is, absolute value part is not new. Go down here, same idea. Square root both sides. The square root of anything squared is going to be the absolute value of that. So it's the absolute value of y minus 3 equals 2. So we get our two answers. Y minus 3 equals 2. Y minus 3 equals -2. Solve each one of those by adding 3 to both sides. Remember how it's the same algebra on both of these? Since they're both y minus 3, we have to add 3 to both of them. That always happens. You always have the same algebra. So we have one answer is 5, and one answer is 3 minus 2, or -2 plus 3, which is +1. So our answers were 1 and 5, just like that. So taking the square root of both sides, knowing that the square root is absolute value, and then solving the absolute value pieces. And we had those, I deleted them. Okay. So try 3, very similar to 2, and see how it goes. Okay, so on the last one, number 3, you got two answers, and they are, yeah, -12 and 2. Okay, good. Let's go down to 6. Only thing different on 6 is that they're not factored. So you have to either recognize how to factor it or go through the steps. So how does this factor? What does that equal, you think? So if you need to, you can say, well, what multiplies to 25 and adds to 10? You come up with 5 and 5. And since they're repeated, that's why we can write it as squared. It's x plus 5 times x plus 5, which is x plus 5 squared. And now you can square root both sides and finish. So the bottom part only has one new step, and that's to do the factoring, and then it'll look exactly like something above. But you can see this is a template. You need something squared equal to a number. That's what your goal is, trying to get something squared equal to a number. Once you get to that point, square root both sides, solve the absolute value, and then you have your two answers. Okay. Any, I'll let you finish it, but you have to square root both sides and finish it.
How do we do that fraction?
Which one? What's 16 divided by 4? 4. Okay. So, and then number 10 is a little bit more challenging because there's a common factor, GCF, that you have to take out. So, number 10, start off by taking out that GCF. And then solving it. Okay? Okay. All right. So I'll have you work on that for the rest of the period, and when you're finished, show me and I'll stamp it off for today.